Assalamu alaikum, dear students. Today we are going to study paper 507021. Okay, this is theory paper and May June 2018, and it has time 1 hour and 30 minutes. It's called paper 2 because this is theory paper. Okay, it has two portions, so marks are also given for the first portion we are going to solve. Okay, which has the 45 marks. What's mentioned here: answer all the questions in this section in the space provided. The total marks for this section is 45. Okay, this is section A, it has 45 marks. Choose from the guesses to answer the questions. You have to choose these guesses to answer the questions. You can see which gases these are. Argon, you know what is argon, carbon dioxide, CO2, carbon monoxide, CO, ethane, C2H6, it belongs to alkane, hydrogen, H2, methane, CH4, neon, Ne from noble gas, ozone, O3, sulfur dioxide, SO2, and sulfur trioxide, SO3. Okay, now let's move forward. What are the questions? Okay, the question is, each gas can be used once, more than once, or not at all. Which gas is used to manufacture margarine? You know that margarine is found from the hydrogenation of oil, okay, vegetable oil. So we use here, right here, hydrogen. Next question. Is used as preservative. So which gas is used as preservative? Sulfur dioxide, okay? Sulfur dioxide is used as preservative. Keep it in your mind. Next, has a molecule that contains only 8 atoms. So you can see here 8 atoms are, this is the ethane molecule, 2 of hydrogen and 6 of hydrogen. So I write here ethane, okay? Next is found from the bacterial decay of vegetable matter. Which gas is found from the bacterial decay? Any hydrocarbon is found, okay? CH4, methane is here, okay? This is found from the bacterial decay. Sorry, we can write here the name as it is, methane. Is formed in photochemical smoke. Is formed in photochemical smoke. So which gas is found in photochemical smoke? Ozone. Okay, ozone is formed in photochemical smoke. Unburned hydrocarbons react with the nitrogen oxide and ozone is formed. So completely combust to form only a gas that turns lime water milky. Okay, there is gas. There is a gas when it is completely combustioned. Okay, so it contains it produces only a gas that turns the lime water milky. So that must be carbon monoxide when it combustion takes place of the carbon monoxide. So it produces only one gas that is called carbon dioxide. You know that how it happens. I'm just writing here to explain you two carbon monoxide. This is called incomplete combustion because it has only one oxygen. So when its complete combustion takes place, so it produces only one type of the gas, which is called the carbon dioxide. Okay, so it turns the lime water milky. Okay, when you pass the carbon dioxide from the lime water, so it milky precipitates are formed. Okay, so which gas combusts to form the only gas that turns the lime water milky? That is a carbon monoxide. Carbon monoxide. Okay, next question is, the elements in the group 7 of the periodic table are called halogens. Okay, what are they called? Halogens. So group 7, which are those? You know their names are fluorine, chlorine, bromine, iodine, and astatine. Okay, fahim, cleaning, bathroom, in, attack. The simple way to. Okay, so explain why the elements in the 7th have the similar chemical properties. The reason is because they belong to one group and they have the same number of valence electrons. Okay, they have same number of valence electrons, okay, which are seven, which are seven. They have seven electrons and which are the same for all of them in the outermost shell, okay. A redox reaction happens when the, because you need to write only one reason because you have one mark, okay. A redox reaction happens when the chlorine gas is bubbled through the aqueous potassium iodide. You can see that what happens here when chlorine is passed through the iodine, okay. So chlorine becomes iodide, it gains the negative charge, it is reduced itself. And the next is iodine, it is oxidized from, it loses its electrons, okay, and becomes iodine. So what happens, describe what is observed during this reaction. Actually the solution was colorless because of the chlorine. But when the chlorine becomes iodide ions, chloride ions, iodide ions are there and they become iodine gas, its aqueous solution is formed, it becomes soluble in water. So solution turns colorless to brown. Okay, solution turns colorless to brown. Actually, iodine itself is the black solid, but when its aqueous solution is formed, so it becomes brown. Okay, so it was iodide ions, but now it has become, okay. Chlorine doesn't have any color when its aqueous solution is formed. Use this equation to explain that oxidation takes place in this reaction. Yes, oxidation takes place how? From 0 it becomes -1, and from -1 it becomes 0. So from -1 to 0 it is the gain of oxidation state. You can say it is loss of electrons. So loss of electron is oxidation. And the second is gain of electron, this is called reduction. Basically this is the redox reaction because both are taking place together. So use the equation to explain that oxidation takes place in this reaction. So you can use that to I, sorry, you don't need to write, no problem, you can just write, just say that iodide ion is oxidized, ions is oxidized, or ions are oxidized to iodine. How? By loss of electrons. When this thing happens by loss of electrons, so this is called oxidation. Next question is, use the equation to explain that the reduction takes place in this reaction. Yeah, of course. Chlorine is reduced from 0 to -1. Okay, you can say by gain of electron. You can say by in terms of oxidation state as well, or in terms of gain of electron. Okay, so chlorine is reduced to chloride ions by the gain of electron, by the gain of electrons. The gain of electrons is also called reduction. Okay, describe test for the chlorine gas. What is test? When you bring the moist red or the blue litmus paper, okay, it turns colorless. Moist blue or green litmus paper. Okay. So chlorine, what you observe? Chlorine turns blue or green litmus paper colorless. Okay. You should know even the petals of the flowers which have their permanent colors, when they are exposed to chlorine or when they are bleached, this is called bleaching. Bleaching turns the uh, means you can say that bleaching makes anything colorless. If you have colorful cloths and you use the bleach, okay, bleach contains chlorine gas, okay, so it has chlorine as a part, its part, okay, so as a component. So when you bleach your colorful colors, they become the white, their color are disappear. So that's why bleach is only used for white colors, okay. So in the same way, when you have petals, when you dip in the chlorine solution or in the bleaching solution, so they become colorless. Same is the function of chlorine. Chlorine bleaches blue and the green litmus paper. When it is called bleaches, so it means turns them colorless, okay. Chlorine reacts with iron to form iron chloride in a closed container. The pressure of chlorine is increased. Describe and explain what happens to the rate of this reaction. You know that chlorine is a gas, okay, plus Cl2 give rise to FeCl3. To balance it, I am writing here 3. Here will be written 2 3s are chlorine are balanced, 2 iron, okay. So this become iron chloride, okay, iron 3 chloride. So describe what happens. Basically, this is the solid. It will not be affected by the increase of pressure. This is the gas, and this is also solid. So what happens when you increase the pressure? So chlorine, the concentration of chlorine is increased. So their collision is also increased with the iron. They react more rapidly, and this with the rate of reaction is increased. Okay, describe and explain what happens to the rate of reaction. On increasing pressure, what happens? Concentration of chlorine molecules is increased, increasing collision. When this happens, then collision is also increased, resulting in high rate of reaction, okay. Okay, you can say pressure is directly proportional to concentration, concentration directly proportional to collision, and collision is directly proportional to rate of reaction. This is just to a short trick that you will memorize by this way, okay. When the pressure is increased, the concentration increases. When the concentration is increased, so collision increases, and definitely effective collision will also be increased, so rate of reaction will be increased. So overall, increase of pressure will increase the rate of forward reaction. Iron chloride can act as a catalyst for some reactions. Explain how a catalyst increases the rate of reaction. Catalyst actually provides the alternative pathway, okay, with the lower activation energy. Catalyst increase rate of reaction by providing alternative pathway, okay, alternative pathway. By decreasing activation energy. When activation energy is decreased, okay, so more molecules will be able to be converted into the products, okay. Reactants will be able, more molecules from the reactants will be able to convert to become product, okay. Barium chloride is soluble salt and barium sulfate is insoluble salt, okay. This is a clue that you must know, that barium chloride is barium Cl2 is soluble, while barium sulfate is insoluble, so write it as barium sulfate can be prepared by the reaction between the aqueous barium chloride, okay, and dilute sulfuric acid. Describe the preparation of the pure sample of the barium sulfate from the aqueous barium chloride and the dilute sulfuric acid. So definitely this is the ionic equation. We mix both of these solutions, okay. So because barium chloride and sulfuric acid, when those both are mixed, those aqueous solutions of these two different compounds are mixed, so barium sulfate is formed, and that is insoluble, so it has to be filtered. So now let me tell you. Aqueous solution of barium chloride and sulfuric acid, H2SO4, okay, are mixed. Okay, so precipitates means insoluble, okay, solid. Precipitates of barium sulfate are formed which are obtained by filtration, okay, as residue because it is left to, okay, because insoluble, so it will be left here, barium sulfate, okay. The other solution, the aqueous solution will be of hydrochloric acid, okay. So aqueous solution of acid, that will be filtrate and this will be residue, okay. So as residue, okay, so to remove impurities from barium sulfate, it is washed with distilled water, okay. Distilled water, it will not affect their pH and will not be soluble, definitely it is insoluble, but the impurities which it contains will be soluble in the distilled water, so those will go down and it will become pure, okay, with distilled water. What you do, you mix first of the all barium chloride and sulfuric acid, you mix them, you get barium sulfate is formed, okay, and hydrochloric acid is formed, then you filter it. By filtration you get the barium sulfate as residue and the filtrate is the hydrochloric acid, okay. So but it contains impurities, you want to get the pure, okay, and dry in the filter folds and dry in filter paper folds. So you get the barium sulfate, okay. So you use distilled water to eliminate the impurities which it contains, and then to dry it you use the filter paper folds in which it is dried, and in this way you get the pure barium sulfate crystals, okay. Write an ionic equation including state symbol for this reaction. Okay, I'm going to write here. What happens, you use the barium what we have, sorry, barium chloride and sulfuric acid, BaCl2 plus H2SO4 give rise to barium sulfate plus 2HCl. So what we do here, it's aqueous solution AQ, so that's why it converts. I am writing here AQ. This is solid and this is also AQ. So we convert all the AQ into their ions, okay. So how would you write here directly? But you need to do it's two steps. So you convert into their ions. What you write? You write barium plus 2, okay, this is aqueous solution, plus 2Cl minus, you also write AQ over here, plus 2H plus AQ you will write, plus SO4 minus 2, what you get, barium sulfate. It won't be converted into its ions because it is insoluble. Then you get 2H plus Cl minus 2Cl minus. So you will see that those which are similar on the both sides will be cancelled, 2Cl with the 2Cl, 2H will be cancelled with the 2H, and the remaining, these are the called spectator ions. Remaining will be the ionic equation. What is the ionic equation? Ionic equation is Ba plus 2 plus SO4 minus 2, you get barium sulfate. These are aqueous, okay? These are aqueous, and this is also aqueous, but this is insoluble. That's why it doesn't convert into ions. So this is the ion equation. Barium. Okay, you may skip this first step. You write simple is this one equation, and then you make the final equation by cancelling. Okay, you may skip this equation because you know this thing now. Because you know that barium chloride and the sulfuric acid are there. You can understand. Okay, instead of writing the balanced chemical equation, you can write it directly. But this is also okay. It will give you full marks. Okay, and you'll be satisfied more. Barium chloride can be prepared by reacting barium carbonate with a dilute hydrochloric acid. You can see this equation is given. Excess barium carbonate is reacted with 40 cm cube of the 1.5 mole per dm cube hydrochloric acid. What is the question? What the question demands? Barium chloride can be prepared. We can get the barium chloride, okay, by reacting the barium carbonate with hydrochloric acid. You can see hydrochloric acid. These both react and barium chloride is formed. Okay, excess barium carbonate is reacted. Barium carbonate is in excess. Okay, so it won't give you the right amount of the product because it is in excess. But what is the limiting? 40 cm cube of the 1.50 mole per dm cube hydrochloric acid. This much volume is used and its concentration is this one. After purification, the percentage yield of barium is 75%, was 75%. Calculate the mass of, what is asking for? The mass of the barium chloride prepared. Now let's start. First find out number of moles of hydrochloric acid. From where we will find out, because limiting reactant determines the amount of product formed, not excess one. Okay, from here, from the amount of the hydrochloric acid, we will find out barium chloride. Okay, and in this way, then its number of moles, and then we can find out its 75% and then mass. Okay, okay, let's start here. Its volume is 40 cm cube. Let's convert into the dm cube. 0.040. Okay, then its concentration is equal to 1.50 mole per dm cube. So what's the formula? Concentration is equal to number of moles over volume. Okay, and you know what we have to do. Number of moles is equal to this volume is dividing here, will be multiplied with the concentration. So what we get, let me write here, number of concentration is 1.50 mole per dm cube, multiply volume is 0.040 dm cube. So this dm cube is cancelled, so number of moles will be obtained. Multiplying is 1.50 multiply. What we get quantity? We need to use here calculator. Yes, we get 0.06. 0.06. Okay. So from here we can find out amount of barium chloride produced. Okay, by ratio method, ICl ratio barium chloride, BaCl2. So ratio method is 2 and it's 1 mole, means it's 2 moles produces 1 mole of barium chloride. So if we have, it's how many moles? This is of ICl. If we have 0.06 mole, then what will be its amount? X. Okay, so 2x is equal to 0.06 and x will be equal to 0.06 divided by 2. It will become 0.03 mole of, okay, of this will be produced. Now we have the mass of the barium chloride 208. We find out its mass. Mass is equal to number of moles multiplied by molar mass. Number of moles are 0.03. Molar mass is equal to given 208. So what it becomes? It becomes 6.24. Okay, but this is the mass of the barium chloride. Okay, but what is told, this is the theoretical mass what we get from the balanced chemical equation, but the actual yield, percentage yield of the barium chloride is 75%. So now we find out the percentage yield. 75%, 75 out of 100, out of 100, okay, multiply by 6.24. Okay, so what we get? We get 4.68 gram. This is the answer. Okay, so how your marks are distributed? First mark for calculating the moles, this one. Second for calculating number of moles from ratio method of ICl, barium chloride. Okay, from ICl, because we have found the moles of ICl, this moles of ICl, okay, hydrochloric acid whose concentration is given, okay, from here. So second is moles of the barium chloride, 1 mark for this, and third number of its mass by simple formula, and then its percentage for this third mark. Okay. Barium ion has the formula, you have seen this, what is its formula? Complete the table about this ion. So electrons, 56 in case of neutral, but it has +2, means it lost 2. So electron is equal to 56, it had already, but it lost 2, that's why it got +2 charge, so it become 54. Protons, proton number is given here, that is 56. Okay, the next is neutron. Neutron is equal to A minus Z. A means atomic mass, minus Z means proton number. 138 minus 56. Okay, what it becomes? It becomes 82. Okay, it becomes 82. So I am writing a electron is equal to 54. Neutron is equal to 82. Proton is equal to 56. This question is about ethanol and ethanoic acid. Describe the ethanol by fermentation. Describe the manufacture of ethanol by fermentation. What is the fermentation? There is called alcoholic fermentation. So how it happens? Actually, glucose solution and yeast are mixed. Okay, this is kept airtight. Okay, at almost 37 centigrade. This is the best optimum temperature at which the yeast can work their best. Okay, so you will see that glucose is formed. Ethanol is formed with the carbon dioxide. Okay, so ethanol is formed from glucose solution which that is 15% almost. Okay, so it can be, means I mean the ethanol. Okay, it can be separated from the rest of the solution, from the rest of the glucose solution by simple fermentation, by simple distillation, because you know that ethanol has a boiling point lesser than the water, that is 78, so it will be distilled out, and water or the glucose solution, it has the more boiling point, even because you know that boiling point of the water will be increased because it contains the glucose, but you will find that ethanol will be separated at 78 centigrade, so we will get it distilled, okay, by distillation. Ethanol can be oxidized by air by oxygen to form ethanoic acid. I'm writing here ethanol, CH3. Construct the equation for this reaction. So, sorry, CH3 we have, and then CH2. This is the ethyl, and when we write all alcohol, so ethanol. So here I'm writing oxygen O2. What will happen? CH3, this carbon and double bond oxygen, okay? Double bond oxygen, and then there will be OH. This hydrogen and one more oxygen will form the H2O. Okay, so it is called oxidation of ethanol. So ethanoic acid is formed. A sample of ethanol is heated with ethanoic acid in the presence of concentrated sulfuric acid catalyst. Draw the, okay, what's written here? Sample of ethanol. We have the sample of ethanol is heated with the ethanoic acid. Ethanol and ethanoic acid are heated in the presence of concentrated sulfuric acid. Draw the structure of the product of this. Show all of the atoms and all of the bonds. Actually, you know that this is ethanol is alcohol and the second is ethanoic acid. When both of these are heated together and sulfuric acid acts as a dehydrating agent, okay, it removes the water molecule, dehydrating agent, okay. So condensation reaction takes place. I mean simply that ester is formed and the one water molecule is released. Okay, ethanol releases its OH, only H, and ethanol releases its OH. OH from here and H from here from the water. So what's remaining from ethanol? Ethyl will be left. One carbon, second carbon. Okay, it had OH. You don't need to write this OH. Okay, it will be left. Okay. Next, this is from ethanol, ethyl will be left. OH it has removed, and hydrogen from here will be removed, so it will form the H2O. Okay, so dehydrating agent is used for that purpose. So ethanoic acid means C, second C, double bond oxygen, oxygen. Okay, then here was H, so H was removed, so it will make the bond with this. Okay, and it has three hydrogen. You can see all the bonds. Simply OH from here and H from here, okay, from here, and OH from here. These both will form the H2O. Why I'm writing? Just to explain. Actually, this is not part of our answer, okay. So what we get the this product. Show all the atoms and all the bonds. I have shown all the atoms and all of the bonds. Draw the structure of the product of this reaction. This is the main product which is obtained. So you have one mark for this, okay. Ethanol is used as a fuel because it contains carbon and hydrogen, so it can be used as a fuel. The complete combustion of 1 mole of ethanol releases this much amount of energy. Okay. A sample of ethanol reacts with excess of the oxygen. Excess of oxygen means that we have no concern with oxygen. This is an excess which will not tell us the amount of the product formed. Okay. The other thing, when this is in excess, the ethanol is in the limiting. Then we use the limiting thing to find out the product. Okay, so ethanol reacts with excess of oxygen to form a 0.240 dm cube of the carbon dioxide. Okay, measured at the room temperature. Calculate the energy released in a kilojoule per mole. In this kilojoule, okay, in this reaction. Okay, let's find out number of ethanol consumed. How will we get to know? From here, we'll get to know carbon dioxide consumed, the number of carbon dioxide produced, the moles of carbon dioxide produced, and from here we'll find out the moles of the ethanol consumed. And those moles will be multiplied by this energy, then we'll get the amount of energy released. Okay, so let's see what we do here. Carbon dioxide, I'm writing here for carbon dioxide. Okay, we have mole and we have volume. For 1 mole of gas, carbon dioxide, there is 24 dm cube, you know, by the molar volume. And if we have 0.24 dm cube, what will be the number of moles? X. Okay, so means I just want to tell you that how much moles are there in this amount of the carbon dioxide which is produced. Okay, so 24x is equal to 0.24, and x will be equal to 0.24 divided by 24. What we get here, we have to use calculator. 0.01, 0.01. So from carbon dioxide we can find out the ethanol. Okay, carbon dioxide by ratio method, and ethanol C2H5OH. You know that is 2 moles produce the 1 mole of ethanol. So if we have carbon dioxide 0.01 mole, what will be amount of ethanol that was consumed by this ratio? Means ethanol, 1 mole of ethanol can produce 2 mole of carbon dioxide, and if we have this much number of moles of the carbon dioxide, what will be the amount of ethanol in the moles consumed? So 2x is equal to 0.01, and x is equal to 0.01 divided by 2. It will be 0.005. This is the number of moles of. Okay, so you know that energy. Next is the energy. Energy. If mole is there, then all we are doing by the ratio method, mole and then energy. 1 mole of ethanol produces how much? 1350 kilojoule. And if we have 0.005, then what will be the amount of? Okay, x is equal to 0.005 multiply 1350. What we get? Energy 6.75 kilojoule. Okay, is it clear? Energy of ethanol. At 1 mole of it produced 1350 kilojoule. So if we have this much number of moles which we have calculated, okay, so what will be the amount of energy? Silicon is non-metal found in the group 7 of the periodic table. Silicon is manufactured by the reduction of silicon dioxide with a carbon. You can see here. So what is the maximum mass of the silicon that can be made from the 300 gram of the silicon dioxide? Now let me tell you, we can also find out by the mass to mass ratio. Mass to mass ratio. Silicon has 28 mass, plus oxygen has 16, multiplied by 2, it will become 32. So basically 60 gram of silicon produces how much mass of the silicon? 28. Sorry, yes, 28. Simply we can ratio means 60 gram of silicon dioxide will produce 28 gram. So sulfur, silicon dioxide and the silicon, if 60 gram of silicon dioxide produces 28 gram of silicon, so if we have 300 gram of silicon dioxide, what will be the amount of silicon produced? So 60x, this is called mass to mass ratio. Okay, is equal to 28 multiply 300, and x will be equal to 28 multiply 300 divided by 60. Okay, we'll have to use our calculator. So what is the mass? 140 gram. Okay, 140. We have another method. If you don't agree with this, that will be a bit longer. Okay, we can find out. Let me try that method as well. But we'll get the same. Okay, so now let's find out what's this number of moles. Okay, moles is equal to given mass over molar mass. Okay, so you have given mass 300 gram, molar mass is 60, so you get how many moles? 5 moles. Okay, so let's find out by this. You know that silicon dioxide molar ratio we are finding, okay, and silicon. It's 1 moles of silicon, okay. Silicon dioxide makes the 1 mole of silicon. If we have 5 mole of this, then how many moles of this will be? X will be equal to 5. Means 5 moles will be produced, okay, of silicon. Is it clear? So what is the mass of silicon? So you know that given mass is equal to number of moles multiply molar mass. So number of moles is 5 and molar mass is 28, that is equal to 140 gram, as you wish. Okay, first what we found from the 300 gram of silicon dioxide, we found its moles, and then 1 mole of this produces 1 mole of silicon by molar ratio. Okay, and if we have 5 moles, okay, how we found moles? Given mass over molar mass, okay. So then what will be the amount? By same ratio, 1:1, then 5:5, okay, then we get the 5 moles. So then we multiply the 5 moles of the silicon with the molar mass of the silicon, that is 28, we get 140 gram. Two physical properties of silicon. Silicon has a giant molecular structure. It has two physical properties. It's non-conductor of heat and electricity, and brittle as well, but you can say insoluble in water because it is so metallite, so insoluble in water. Hard and brittle, you can also say. Silane, silane has the molecular formulas SiH4. Draw the dot and cross diagram for silane. Silicon, you know that how many it has the mass 14, 2, 8, and 4. So it means it has 4 electrons outermost, so it will share 4 electrons, okay. So let's represent the electrons of the silicon by the dot, okay. And hydrogen, you know that it has only 1 electron, so it will be represented by a cross, okay. We only show the outermost electrons, only need to show the outer shell electron of the silicon. So I am writing here silicon in the mid, then 4 hydrogens are sharing, each one is sharing its 1 electron with the silicon. So this is silicon, it has dot, okay, and this is hydrogen. The electrons are represented by cross, dot and cross, okay. In this way, duplet of hydrogen and octet of silicon are completed, and we get this outermost dot and cross diagram of the silane. Using ideas about the structure and the bonding, suggest why silane has the low boiling point. It has actually simple molecular structure. Okay, silane has simple molecular structure. Unlike silicon dioxide, that is giant molecular structure. Okay, so when you think about the silicon dioxide, then it has giant molecular structure and it has an extensive network of the covalent bonds. So that's why its boiling point and melting point is very high. Okay, but in case of silane, that is, it has the simple molecular structure. So weak intermolecular forces exist. Hence, it has low boiling point. Okay, let's see. Uh, Siloxanes. Siloxanes are condensational polymers. Okay, you have studied condensation polymerization when two different types of monomers combine. The partial structure of Siloxane, okay, can be represented as what is meant by the term condensation polymerization. Now let's say what is condensation polymerization. Type of polymerization with the different monomers polymerize to form polymer by release of small molecule. In condensation polymerization, the small molecule is released when the two different polymers are, that can be water, that can be carbon dioxide. Okay, the small molecule is released. This is called different monomers when polymerized and to form the polymer. Okay, by release of small molecule is called condensation polymerization. Draw the repeat unit of this siloxane. Repeat unit starts from oxygen, silicon, two methyl groups are attached. Then oxygen, you find the silicon to or two methyl, then oxygen, silicon. So I think it starts from, you can say that this is the repeating unit. It's repeating again and again. Okay, oxygen, silicon, and two oxygen, silicon, and two methyl groups are there. So draw the repeat unit. Oxygen, silicon, CH3 group is there, CH3 group is there, then this is the, okay, it's the repeat unit. Like this we write it. Butane forms an additional polymer called polybutene. Okay. Draw the partial structure of polybutene. You must show at least two repeat units. Actually, it has the additional polymerization, and you know that in additional polymerization, unsaturated compounds are used. You have seen that double bond. Unsaturated means which have the double bonds. Okay, so this pi bond, it has one strong bond and one weak bond. The weak bond, which is called pi bond, no problem. You don't know if in the O level it's not told, but in the other one is called pi bond. It is broken down and it is used in linking uh, with the previous and with the next, okay, molecule. So we find here carbon single bond, carbon double bond converts into single bond because it has to form linkage with the next carbon. Okay, so next carbon which has double bond is also converted into the single bond because it has to form linking with the previous and with the next. Okay, it has CH2 and CH3, and here is hydrogen, hydrogen, hydrogen. Here is once again CH2 and CH3, and here is hydrogen, hydrogen, and this is also hydrogen. So draw the partial structure for polybutene. Polybutene means there are many number of, poly means many number of butenes. This is the macromolecule. So that's what we'll have to write here. After writing two repeating units, we'll have to write here n, means these molecules are repeated again and again. Okay. Okay, we have section B. Okay, and three questions from the section are spaced provided. Okay, total marks for this section is 45. Sorry, 30. 30 plus 45 becomes 75 total marks. Okay, for theory. So copper pyrites is an ore compound of the copper. One of the compound in the ore is what we call it, cuprous iron. You can say sulfate, or you can say that copper pyrite. Okay, it's one of the compound is CuFeS2. Calculate the mass of the copper in 20 tons of the CuFeS2. Okay, first we'll have to find out the mass of the CuFeS2. Okay, so copper has mass how much? 64. Okay, let me find out the molecular mass of this CuFeS2. The mass of this is copper has 64, iron has 56, sulfur has 32, but two atoms will have 64. Okay, 64, 56 and 64, it becomes 184 gram per mole, means 1 mole of this. So you can see from here copper FeS2, when it will be decomposed or it will be combusted, it will form one copper because it has one. Okay, so one copper has mass how much? 64. So we can write here a mass to mass ratio. Okay, CuFeS2 ratio copper, so its mass is 184, so its mass is the 64. And if we have 20 tons, okay, don't worry, this is in grams, so this is in tons. The ratio will be same in the tons and in kg. Okay, we will write at the end the tons. Okay, so what will be the amount of this produced? So what we get here, 184x is equal to 20 multiply 64, and x is equal to 20 multiplied by 64 divided by 184. Okay, so when you calculate out, you find out that this is 6.96 tons. Why are we writing tons? Because this was in tons. In grams we are comparing, but then there is tons, there are tons, so the ratio is the same. Okay, in this case, construct the equation for this reaction. What is the reaction? Copper iron sulfide or sulfate, you can say, is heated in air. Copper oxide, copper 2 oxide. Copper 2 oxide, what is copper 2 oxide? Cu plus 2, and oxygen has minus 2. Okay, so 1-1 ratio, 2-2 ratio, but 2 will be cancelled with each other, 1-1 ratio. It means CuO, its formula will be. And the iron oxide, iron plus 3. So what is the iron? Fe plus 3, and oxygen has minus 2. Okay, 2 ratio 3, so you get Fe2O3. Okay, so what we get, it is told here copper FeS2 is heated in air and air contains oxygen. So what we get, copper oxide CuO plus iron oxide Fe2O3 plus what we get, sulfur dioxide SO2. Now let's find out. Copper is 1, copper is 1, iron is 1, iron is 2. It's issue over here. I will have to write here 2. But when I wrote here 2, Fe2 is okay. O3 is also, sorry, Fe2 is okay. But copper has also become double, so I will have to write here 2 copper and 2 iron. 2 copper and 2 iron, it's okay. Now let's see sulfur. 2 2s are 4, 4 sulfur, then I'm writing here 4. Now let's find out the number of oxygen. 2 1s are 2, this 3. Okay, 2 plus 3, it becomes 5, and 4 2s are 8. 8 plus 5, it becomes 13. So I will have to write here 6.5, so that 6.5 multiplied with the 2, it will become 13. Construct the equation for this reaction. What is the reaction? Copper oxide can be reduced by heating with the carbon. Reduced means the loss of oxygen, okay, with the carbon. So copper oxide is basically formula CuO plus, it is reduced when it is heated with the carbon. So what will be formed? Cu will be formed and carbon monoxide will be formed. But when you take, this is one of the equation. But you can also write, if you have copper oxide in the excess and the carbon is in the limiting amount, then carbon dioxide will be formed. How? So write CuO2, it means it is in excess, then carbon, then 2Cu will be formed, and then carbon dioxide. Both equations are right. Okay, you may write any of these. Okay, this depends upon the situation. If we have copper oxide in excess, then carbon dioxide will be formed, and if we have carbon and copper oxide both in the same amount, then carbon monoxide will be formed. Okay, copper made from this reduction is impure. Impure copper can be purified using the electrolysis. Name the electrolyte used. Remember that we'll have to use the any copper salt. Okay, so we can take copper aqueous solution of copper sulfate or nitrate. Okay, means this which thing, the thing, the any metal which has to be purified, then salt, aqueous solution of its salt has to be used as an electrolyte. Okay, what are the electrodes made up of? Positive electrode, which is called anode. Anode is made up of always impure copper, which has to be purified, okay, by electrolysis. Negative electrode, it is made up of the pure copper, on which the from here impure, the pure copper will be oxidized and then it will be deposited while going through the copper sulfate electrolyte on the negative electrode cathode. Okay, copper, pure copper. Okay, write equation that on the both electrodes. Positive, you know that on the positive electrodes it is called OA, oxidation on anode, and negative Cr on the cathode, that takes place reduction. Okay, what is oxidation? Oxidation means the loss of electron. Okay, so copper will lose electron. This is a solid. Okay, okay. So anode, which is made up of impure copper. So impure copper, impurity will not be oxidized. Only the copper will be oxidized, and it will become Cu plus 2, and 2 electrons will be lost. Cu plus 2, it is called aqueous. Okay, so this copper, this is oxidation which has taken place on the anode. Now copper plus 2 aqueous, 2 electrons are added into it. Okay, so its reduction takes place, means gain of electrons is called reduction and loss of electron is called oxidation. So it becomes Cu and solid, copper solid. It will be deposited on the cathode. A scientist investigates the reaction of the iron with the steam in the closed system. Reaction of iron with, you can see that steam. Okay, so dynamic equilibrium is established. It's okay. Explain why the concentration of the steam and of hydrogen do not change once the dynamic equilibrium has been established. You know that in the dynamic equilibrium state, okay, the concentration of the reactants and products remain constant. At dynamic equilibrium, concentration of reactants and products, okay, it's not working well over here. Remains constant. That's why its concentration is not, because rate of forward and reverse is equal. Because forward and reverse reactions equal. Okay. Simply you can write the equation. At dynamic equilibrium, rate of forward reaction are equal and the concentration of the reactants and products are constant. You can write this definition, okay, because it's asking for the explanation. Pressure of the equilibrium mixture is increased. The temperature of the closed system is kept constant. Read it and explain what will happen if anything to the composition of the, yes. When the pressure is increased, so it moves from the higher moles to the lower moles. Pressure only affect the gases, okay? Okay, so when the pressure is increased, so from the higher moles, the gases tend to towards the lower moles. So solid will not be affected. Here are gas, and this is they will be affected. But here is 4 mole of water, and here is 4 mole of hydrogen. So increase of pressure or decrease of pressure will have no effect. Okay, because both are equal. Okay, so a number of moles of gases, okay, on the both side of the equation, on the both side of are same. So change of pressure, or you can say increase of pressure, okay, will not affect rate of reaction. Okay, at dynamic equilibrium, okay, at dynamic equilibrium, number of moles of the gases on the both sides of the equations are same. Okay, so the increase of pressure will not affect the rate of reaction. The temperature of the equilibrium mixture is increased. When the temperature of the equilibrium mixture is increased, the pressure within the closed system is kept constant. Pressure is constant, temperature is increased. The position of equilibrium shifts from the left, shift to the left side. This is the right side and this is the left side. So equilibrium shifts towards this side. It means this side is endothermic. So what it means, this side will be exothermic. So it means the rate of forward reaction is decreased and rate of reverse reaction is increased. Position of equilibrium shift to the left side. What conclusion can be made about this enthalpy change of the reaction? This is the exothermic reaction, because from the forward reaction we find out which is the enthalpy change. Okay, this is exothermic reaction. Describe and explain what happens with the rate of reaction. Okay, when the rate of when temperature is increased, so what happens? Kinetic energy of the molecules is also increased. Product molecules is increased. It increases. Okay, so resulting high collision and high rate of reaction. Systematically you will have to write. Okay, means when the temperature is increased, so kinetic energy will be increased, and when the kinetic energy is increased, so number of collision will be also increased, so rate of reaction will be also increased. Anything which increases the number of collisions, so the rate of reaction will be increased. Dilute sulfuric acid reacts with the iron oxide. Sorry, this which type of this is Fe3O4. This is an iron oxide. Okay, so to form three compounds A, B, C. One is the iron sulfate. Second is iron 2 sulfate. Okay, this formula is Fe2. Sorry, FeSO4. FeSO4. Sorry, FeSO4. Okay, so iron 3 sulfate Fe2SO4. Fe2SO4. This is also produced Fe2SO4 thrice. You will be how it is Fe2 Fe plus 2 and SO4 minus 2. Okay, 1:1, so it becomes FeSO4. The next is Fe plus 3 and SO4 minus 2. Without charges, they will come 2 and 3. Okay, so it will come Fe2 and SO4 thrice. And the colorless liquid. What will be the colorless liquid? This will be definitely water. Okay, because from sulfuric acid you know that it has H2SO4. Okay, iron sulfate, iron 2 sulfate, iron sulfate. So hydrogen and oxygen are remaining, so they will form water. Got it? From the common sense we can make it, we can uh, we can make them into use, that iron sulfate, iron 2 sulfate, iron 1 sulfate. So what about this hydrogen and oxygen? What have we found? Construct the equation for this section. Okay, let's write equation for this. Fe3O4 plus H2SO4. Three products will be formed. FeSO4 plus Fe2SO4 thrice plus H2O. Simply, let's find out. 3 Fe are here, 1 Fe and 2 Fe, it's okay. Sulfate, sorry, oxygen. 4 oxygen are here, I can write here 4, then it will become 4 oxygen, it's okay. But now let's see hydrogen. Hydrogen 2 are here, here is 2 hydrogen, it's okay. Now find out the sulfate. The issue is with the sulfate, okay. Sulfate is 1 here, but here 1 this and 2, 3 this, it's become 4. But here is only 1. So if I use, how can I make it 4? If I write here 4, then 4s2 and then 4s2 will be formed. Okay, I'm writing here 4. Okay, writing 4 is okay. Now let's see what happens. Fe3, Fe1 is here, Fe2 is here. It's okay. Oxygen 4. Okay, to balance it 4, I'm writing here 4. 4s2, 4 oxygen are here. 4 hydrogen, 4 twos are 8 and 4 twos are 8. Sulfate, how many? 4 sulfate, 4. Okay, 1 sulfate is here and 3 sulfate are here, then 4. It's balanced, okay? Describe the chemical test for iron ions. What is the chemical test for iron ions? This is for iron 3 ions. Adding aqueous sodium hydroxide. Okay, we add the aqueous sodium hydroxide. So precipitate of iron sulfate FeOH thrice will be found, which has the brown color. Okay, so you don't have to write this thing. Okay, don't worry about it. Just write observation that brown precipitates will be observed. So which indicates that this is there is iron 3. Okay. Methane, sulfonic acid. Methane and then sulfonic acid. Write the molecular formula. It is C1. Hydrogen how many? 3 and 4. H4. Sulfur 1. Oxygen how many? 3 oxygen. Okay. Then what is? Methane sulfonic acid is a stronger acid than the ethanoic acid. What do you mean by stronger acid? That it produces more number of hydrogen ions than the ethanoic acid. Explain the meaning of this statement. Basically, methane sulfonic acid is a stronger acid than ethanoic acid because it produces more number of H plus, more concentration of H plus ions in aqueous solution. Any acid which produce more number of the H plus ions is called strong acid. Okay, and this produces less, so it is the weak as compared to the methane sulfonic acid. What is the difference between an aqueous acid and aqueous alkali in terms of ions? Aqueous acid is one which produces more number of which contains the H plus ions, and aqueous alkali is that which produces OH. Okay. Aqueous acid contains, in terms of ions, is asking for, contains H plus ions, while aqueous alkali contains hydroxide ions. Okay. What is the mass of methane sulfuric acid needed? 150 cm cube of this much concentration of solution. Simple. We have its volume 150 cm cube. Okay. So by 1000 we'll divide, so we'll get 0.15 dm cube. We have its concentration. Concentration is equal to 0.150 mole per, we can also write 0 as well over here, per dm cube. Number of moles we have to find of it. Okay, so that we may multiply its number of moles with its molar mass. Okay. So you know that concentration is equal to number of moles by the volume, and the number of moles is equal to this volume will be multiplied with this concentration multiply volume. Okay, so I'm writing here their values 0.150 mole per dm cube multiply by volume is 0.150 dm cube. dm with the dm cube will be cancelled. Okay, what we get over here, you'll have to use the calculator over here. Yes, you will get here some value. Okay, you'll have to use calculator over here. That is 22 point. That is, you can say simply, this is 0.225. Okay, moles. Now let's find out the relative molecular mass of the methane sulfonic acid. Okay, so relative molecular mass is, it is actually CH4SO3. So carbon has 12, hydrogen has for 4 atoms 4, for sulfur 32, oxygen 48 for 3 atoms. What it becomes? It becomes 96. Its molar mass. Okay, so mass for this will be equal to, we have the number of moles multiplied by relative molar mass. Okay, so number of moles 0.225 moles. Okay, sorry, 0.0225 multiply by 96. So what you get? 2.16 gram. Okay, this is the answer. Simply, what we had to do it, mass of the methane sulfonic acid. We had to find the mass of methane sulfonic acid. We were given its volume. This is called volume. Okay, this is called volume. Sorry, and this is the concentration. Okay, we were given its concentration and volume. We wrote here the volume, okay, in the dm cube, and then we have the concentration, number of moles had to find. So this is the formula. Okay, keep it in your mind. It's the formula. So we found the number of moles. Okay, and this is the number of moles, and when we have number of moles, we multiply with the molar mass, and simply we had to get it. Okay, that is the 2.16 gram. In titration, 0.00150 mole of NaOH is exactly neutralized by 0.150 mole per dm cube of the methane sulfonic acid. 1 mole of sodium hydroxide, okay, reacts with 1 mole of the methane sulfonic acid. So it's clear from here that it's if the 1 mole of NaOH reacts with 1 mole of methane sulfonic acid, so it means this much number of moles. If the NaOH is completely neutralized, so it means the number of moles of the methane sulfonic acid is equal to same. Okay, 0.00150, and this is concentration. We calculate the volume in cm cube of the aqueous methane sulfonic acid needed this titration. So simply what we have to do, this titration it told that 1 mole of NaOH, 1 mole of NaOH react with 1 mole of methane sulfonic acid. If it has this much number of moles, okay, so how much number of moles will be neutralized of this methane sulfonic acid? The same. Okay, so, sorry, we can write here again CH4SO3 and NaOH. Okay, and if we have it's 1 mole, it's 1 mole will be neutralized. Okay, if we have 0.00150 x, so x will be equal to 0.00150 of the methane sulfonic acid number of moles. Okay, so what we have next thing, we have given its concentration, which is equal to 0.150 mole per dm cube. Okay, so you know that concentration is equal to number of moles over the volume, and number of moles is equal to concentration multiplied by volume. Okay, now let's write their values. Concentration is equal to 0.175 mole per dm cube. Sorry, not here we have number of moles, not the volume. So what we have to find? Volume. Volume is equal to number of moles divided by concentration. So number of moles is equal to 0.00150 divided by concentration is equal to 0.175, okay, mole per dm cube. So what we get here, after calculating, we get here 0.0085, 0.0085, but this will be in the dm cube. Okay, so we have to convert in the cm cube. You know that 1 dm cube contains 1000, so 0.0085 multiply with 1000, then it becomes in the cm cube. What we get value 8.57. okay, 0.57 is also here, 8.57 cm cube. This is the volume. Methane sulfonic acid react with the manganese to form the salt and the gas. And this is the acid, and react with the magnesium, this is the metal, to form salt and gas. Name the gas. You know that when the acid reacts with the acid plus, this is just to tell you, plus metal, what we get? Salt plus hydrogen. Okay, so this is gas. The formula of anion in the salt is this one. Formula of the salt, this magnesium. Okay, it's asking about the magnesium. You know that magnesium has +2 charge, and anion is a CH3SO3 minus. Okay, cross multiplication 1 time, 2 times. So Mg is 1 time, and 2 time it will be CH3SO3 twice. So this will be the formula, Mg CH3SO3 twice. Methyl propane is saturated hydrocarbon. It's okay. Methyl, and this is the propane. Methyl propane reacts with the chlorine in the presence of ultraviolet light to give the several compounds. one of the compound has the relative reacts with the chlorine. Okay, relative molecular mass of the 170. What's the molecular formula of compound? Okay, let me tell you what's the form methane propyl methyl propane. Basically, this is a C4 and H how many? 10. This becomes 48 plus 10, it becomes 58. So when we have to make 58 170 127, then it means its two hydrogen has to be replaced. Okay, so then its formula will be its molecular mass be 127, and the formula will be, for example, C4H8 and two chlorines replaces the two hydrogen, because this is the substitution reaction. This is the alkane which shows the substitution reaction. So now let's find the mass. 48 for carbon, 8 for hydrogen, and 71 for chlorine. 9 and 8, 7, and 9 and 4, 13. Sorry, this becomes 7, 8, 8 and 4, 12. Yes, this is the formula. C4 HO8 and Cl2. Then its formula will be 127, and the molecular compound will have the molecular formula. This one. This is the mass of that molecular formula. Okay. So that's the structure of this compound. Show all the atoms and all the bonds. So you have to show 3 carbon. Methyl propane is there. You can show chlorine over here and there. One chlorine you can show here, and one here. Okay. Rest of the hydrogen atoms will be there. Okay. Okay. This becomes C4 H8 1 2 3 4 5 6 7 8 and Cl2. Okay. Another compound formed has the percentage composition by mass. This is the question. So carbon has, you know that you have to find its formula, molecular formula. So here percentage is given. Carbon is there, hydrogen is there, chlorine is there. Okay, so you find 29.7. Okay, the 4.365.9 divide by their atomic mass is 12, 1.008, 30, or you can simply write one. Okay, 35.5. What we get over here? You'll have to use the calculator. Okay, then there will be 2.5. Okay, then there will be 4.26 number of moles, and there will be 1.85. Now let's divide the 2.5 by each of them, means the least. Sorry, 1.85 will be multiply 1.85, 1.85, 1.85. Okay, means the number of moles which are the least are divided by all of those. Okay, so here you can use the calculator to find out number of moles. 2.5 divided by 1.85, you get 1.35. Okay, next is 4.26 divided by 1.85, so you get 2.3. Nice. Then here is 1 point, then you get here 1. Now you have to multiply with the suitable digit to make them whole number. Okay, you know 3.35 and 30 is 1/3 of 100. So if you multiply all of these with the 3, so it will become 4. Carbon will be 4, hydrogen and chlorine. Okay, so it will become 3, so it will become 7. and 3 ones are 3. So simply you can say C4H7 and Cl3. This is molecular formula. A compound is formed when 1 mole of the methyl propane reacts with the 5 molecules of chlorine. What is the molecular formula of this compound? When five molecules of chlorine react, so each molecule will be able to release one hydrogen. So it means C4, it was H10, so it will become H5 because 5 hydrogen have been substituted by 5 chlorine. Okay, because they substitute, you know that 5 molecules. Let me tell you, when we have C4HO10, then we used one chlorine molecule. What happened? C4HO9 and Cl plus HCl was formed. So when we used one chlorine molecule, so one hydrogen was substituted. If we use C4HO10 and we use 5 chlorine, what will happen? C4HO5 and 5 chlorine will replace the 5 hydrogen. Okay, and what will be formed? 5 hydrogen which have been replaced will react with the rest of the 5 chlorine atoms, so 5 HCl will be formed. Okay, so this is C4H5 and Cl. This is the formula, molecular formula. The structure of propene and the cyclopropane are shown. You can see the structures. The two compounds are isomer of each other. What is meant by that term isomers? Same molecular formula but different structure formula. Same molecular formula but different structural formula. What is meant by the term hydrocarbons, which are made up of only hydrogen and carbon? Made up of only compounds made up of only carbon and hydrogen atoms. Propane is an unsaturated hydrocarbon and cyclopropane is saturated. What is the difference between an unsaturated and saturated hydrocarbon? What's the difference? Propane is an unsaturated. So unsaturated has a carbon-carbon double bond, and saturated has carbon-carbon single bond. Okay. While saturated has carbon to carbon single bond. Describe the chemical test distinguish between the, we call it bromine water test. Okay, bromine water test. Okay, so what happens? Unsaturated hydrocarbons okay convert the bromine into colorless, make the bromine solution colorless. Orange solution of the bromine colorless. Unsaturated hydrocarbons while saturated don't. While saturated don't. Okay, so here is the end of your chapter. Thanks for watching this video. See you in the next lecture.